Very good morning, friends. Today we are going to discuss about hydrohalogenation of alkenes. It is the addition of hydrogen and halogen across a carbon-carbon double bond. And when this hydrogen and halogen adds across the carbon-carbon double bond, I'll get haloalkanes. What are all the hydrogen halides which can add across the carbon-carbon double bond? It includes HCl, HBr, and HI. Hydrogen fluoride can also gets added up across the carbon-carbon double bond to give corresponding alkyl fluorides. But however, due to the low acidity of HF, it requires strongly acidic conditions, which requires a different set of reaction condition. That's why normal reaction conditions what we use for HCl, HBr and HI do not holds good. Like that of hydration of alkenes, the hydrohalogenation of alkenes can follow electrophilic addition mechanism. The pi bond breaks, adding a hydrogen atom to one carbon, and the another halogen atom adds to the other to give haloalkene. The reaction includes the reaction of alkene with HCl. Halogen is an easy leaving group, and that's why it pulls its electrons towards itself, making electron rich, which we represent here as delta minus. As it has pulled the electrons towards itself due to its electronegativity, the hydrogen will have lesser number of electrons, which is represented as delta positive. Because of the electronegativity of halogen, there is unequal sharing of electrons between hydrogen and halogen, making HCl as a polar reagent, having the two poles, the positive pole and the negative pole. In the presence of HCl, the H plus, it acts as an electrophile and it gives rise to electromeric effect in the alkene. And that's why the reaction occurs. In case of hydration of alkenes, we added a acidic reagent as a catalyst like concentrated sulfuric acid. Here we do not require any catalyst. It itself reacts because of the fact that it is highly polarized HCl, and at the same time chlorine is an easy leaving group. Any halogen is an easy leaving group. It gives rise to corresponding alkyl halides. It also follows the mechanism similar to that of hydration, that is electrophilic addition mechanism. It is similar to that of hydration of alkenes. The mechanism involves the protonation of alkenes. H plus, electron deficient hydrogen, it acts as an electrophile. In the presence of H plus, an electrophile, the pi electrons moves towards the one carbon of an alkene. Once this electrons moves towards the alkene, it becomes electron rich, rendering this electron rich carbon, that is nucleophile, it is nucleophilic in nature. It attacks on this positive center, and as it attacks on the positive center, it has to maintain its valency. That's why hydrogen and halogen bond breaks and chlorine gets removed as chloride ions. As these electrons are moved towards this carbon, and this electrons rich carbon are shared its electrons with hydrogen, a new electrophilic center has been created. As the electrons are moved towards this carbon becomes electron deficient, and a carbocationic center is formed. As this is electron deficient molecule, it is unstable. And chloride ion, which is electron rich, that's why it is also unstable. To become stable, both of these molecules react. Chloride ion, which is electron rich, attacks on the electron deficient carbon, and the nucleophilic attack takes place, and it gives rise to corresponding haloalkane. Here we do not require any catalyst, as HCl is a polarized molecule, and at the same time halogen is an easily leaving group. That's why the reaction is much more simpler. It requires ambient reaction condition than that of hydration of alkenes. The salient features of hydrohalogenation is that addition of HCl and Hi follows Markovnikov's rule, like that of hydration of alkenes. What is this Markovnikov's rule? As we know, hydrogen adds to the carbon which is least substituted, whereas addition of hydrogen bromide follows anti-Markovnikov's rule. That is, hydrogen adds to the carbon which is more substituted. What makes hydrogen bromide so special? Why hydrogen bromide follows anti-Markovnikov's rule? When this was digged out and explored, it was found that the hydrogen bromide which we use and which is commercially available contains peroxides as impurities. These peroxides are the culprits which changes the mind of hydrogen bromide. These peroxides makes or alters the mechanism of reaction. As we know that hydrogen halides addition across carbon-carbon double bond follows electrophilic addition reaction, or electrophilic addition mechanism to be precise. Because of the presence of peroxide, it alters the mechanism of addition. Instead of following electrophilic addition mechanism, hydrogen bromide addition to alkene follows free radical addition mechanism. How is it? How it alters the mechanism? How free radicals are formed? That will be the subject of discussion for the coming presentation. Till then, have a nice day. Thank you.